Hello everyone. Today we're going to introduce you the fluid properties in SimCenter MSim. Our learning objectives are to get familiar with fluid property parameters based on a simple example model. Also, we need to know the difference between fluid property models with different complexity. Let's start with a small model as shown on the right-hand side. First, please add a fluid icon, a variable source, and a sensor for fluid properties to the SimCenter MSim sketch. This is the simplest way to test fluid properties. Then in the submodel mode, we choose FP04 submodel under fluid property parameters. Then go to parameter mode, and now you have finished the first circuit model. As we're going to present you different fluid type properties will lead to different simulation results. You can also copy-paste this circuit model for 4 times in sketch mode to view the results in one simulation run. Okay, let's create the model together. First, we pick up this fluid icon, and then a pressure source, and our fluid property sensor. So now we have a simple circuit model, and go to submodel mode. You can select the fluid property model with this FP04, and the rest we use Premier submodel. Okay, now the first model is finished. Okay, we can copy paste it 4 times in sketch mode. And then we can set this fluid index so that it can represent different fluid property with different complexity. We can select the fluid properties type here in this parameter. So for the first one, we use the simplest, and for the second one, we just use the default option, elementary, and for the third one, we use advanced. For the fourth one, we use advanced using tables, and for the last one, we use the Robert Bosch, the adiabatic diesel. And now we have finished the creation of these 5 different models. You may notice that there is an index of hydraulic fluid inside the fluid property component. It's an identification number, which enables to study a system working with several fluids. For example, you could have oil and coolant circuit in an automotive engine model. Then, in this case, fluid icons for engine lubrication circuit and coolant circuit must use different indexes. In fluid property sensor, the only parameter to set is also the index of hydraulic fluid. That means once you put this sensor in your circuit model, you need to set this parameter same value as it's in the fluid property component. For more detailed and complete fluid properties calculations, you can find in the help document of SimCenter MSim. As we can see from the simple MSim model, the first option of fluid type is simplest, but it's rarely used now because it's a very simple model and assumptions. The second one is elementary. It's closer to real fluid in circuit, and that's why it's set as default option. Compared to elementary, the option advanced gives additional access to aeration and cavitation related parameters. The option advanced using tables is to be used when you have the characteristic data of fluid property. Then it allows you to create an ASCII2 file to define fluid properties as a function of pressure and temperature. There is also a dedicated fluid called Robert Bosch adiabatic diesel. It was a diesel property model developed together with Robert Bosch GmbH and validated against the measurement data. So if you're going to build diesel engine fuel system, such as injector, common rail, fuel pump, etc., this fluid property option shall be a proper choice. Now let's go back to the small models. We will go through the results of different fluid property models. The fluid property type is simplest. In the plot, it's the red curve where the bulk modulus switches from 0 to 17,000 bar at 0 bar. Because the saturation pressure is 0 bar, obviously it's unrealistic to have this kind of bulk modulus characteristics. Please be aware also the parameter temperature, air gas content, and the polytropic index won't affect simulation results. Then with elementary and advanced fluid property types, we can see from the results plot that bulk modulus are gradually changed along with pressure variation, which is more realistic. Moreover, for advanced fluid type, the vapor pressure values can be changed, and from the results curve, the yellow one, we see the bulk modulus decrease more rapidly at minus 0.5 bar, which can be interpreted that cavitation starts to happen and it impacts the fluid bulk modulus value. For fluid time that is associated with tables, there are two options. For first option, there are already a lot of commonly used fluids covering different industry domains, such as engine lubricant, 5W30, 15W30, or engine coolant, where pure water and glycol are mixed with certain percentages. All these ready-to-use fluids properties are stored as built-in database in MSIM. For second option is a user data file, where we can define the fluid density, bulk modulus, and viscosity as functions of different temperature and pressure levels. There is a detailed description in the help document, and you can follow the description to create your own fluid. As a brief summary of this short lesson, you have learned what parameters are accessible in different types of fluid property model, and for different complexity of fluid property model, some parameters will not impact the simulation results, even they appear in the component parameter list. With this, we end our lesson on parameters of fluid properties. Thanks.